First thing I want to talk about is what types of factoring have we done? How do I know what type of factoring I can do? And on top of that, I want to talk about the fact that the very first thing we talked about was factoring using a GCF, right? You guys remember doing that where I just looked for a GCF, I could factor that out with parentheses. You can always look for a GCF. And if there is one, that is the very, very, very first thing you should do. So today, these aren't going to be like separate sections where it's like, oh, I've got a section for factoring trinomials, a section for factoring special cases, a section for grouping. It's all going to be mixed together, okay? So the very, very first thing that I want you to always check for is a GCF. So we're gonna kind of do like a flow chart here to help organize it. So the first thing, so I would kind of leave yourself some space on your paper there. Check for a GCF. Okay. So you're going to pull out a greatest common factor if you can. There may not always be one. And then after you do that, or if there is no GCF, then we've got to move on and see if it meets like one of the other cases that we've done. Okay? So I'm going to start with, does it have 4 terms? Okay. Because if it has 4 terms, does anybody remember the method that we used there? No. Okay. If it has 4 terms, we need to use grouping. Okay, factoring by grouping. Hopefully you guys remember that. If not, we'll go over an example here shortly. If it has 3 terms, okay. If it only has 3 terms, that's our trinomials, and there were 2 different types. Ones where there were leading coefficients of 1, and then ones where there was a leading coefficient other than 1. So I'm going to put leading coefficient. I'm just going to abbreviate that. If it has a leading coefficient of 1, and I'm just going to put a real quick example underneath that. That's where we go straight to the x and x. And then you have to fill in the blank with what this number, or what those 2 numbers need to be. And then if we have a leading coefficient that's not 1, those were a little bit harder. Okay? You still are going to set up your 2 parentheses. But this time you have to kind of check all, like both, the first and the last. And then check the middle. Okay? And we'll go over some examples of each of those. And then lastly, if I just have 2 terms, you guys remember any type of factoring for 2 terms?
FOIL?
No. Like if I'm trying to factor an expression that only has 2 terms, there's only one method that we did there.
The squared one.
The difference of squares. So if there's 2 terms, the only method of factoring that we have is a difference of squares. Okay. So this is kind of going to give you a flow chart for organizing. Whenever you see a problem, the very, very first thing, check for a GCF. If it has a GCF, then check to see if you can factor again using one of these 3. or 4, technically. If there is no GCF, still come over here and see if you can use one of these methods. Okay, does that make a little bit of sense? Now, what if I have something that only has 2 terms, there is no GCF, and it's not a difference of squares? Then it's just not factorable. The only way we can factor with something with 2 terms is either a GCF or a difference of squares, or both. If I have 3 terms, it's got a leading coefficient of 1, but there's nothing that makes that first, middle, and last term work. You would have to go through and exhaust every combination, but if none of those work, then it's not factorable. Okay? All right, let's jump into some examples. All right, so if I take a look at this, very, very first thing I should always do is what?
Check for greatest common factor.
Check for a greatest common factor. Every single time, every problem. Check for a GCF. Is there a GCF?
6.
There is a GCF of 6. So factor out a 6. That means I divide every term by 6. You also want to check for variables as well, but they don't have a variable in common for all 4 terms. But when you're checking for GCF, it's numbers and variables. Okay? So I divide all these by 6. Okay. Then I need to check, can I factor what's left? Because sometimes I may not be able to. Sometimes it may just be a GCF and then I'm done. Okay? But I need to look at what's left. It has 4 terms. So what method did we have there?
Grouping.
Grouping. I need to see if I can factor it by grouping. So if I group the first 2 terms and the last 2 terms, do these have a GCF?
No. 1.
So no.
Variables.
Oh, X is
Yeah, they do have a GCF of x squared. So I factor that out of those 2 terms. And then I go to the second 2 terms. Do those have a GCF? No, but for grouping, if they just have a GCF of 1, we're going to put that. And so if I divide by 1, I still get 2x minus 3. You remember for grouping, I'm looking for these parentheses to match. They do, so I can combine those into one set of parentheses. And then what's left in front there goes in my second parenthesis. And then don't forget this GCF has to come down out front, otherwise
Wrong.
it would not, well, it would be wrong, but it wouldn't be equivalent to the equation that we started with. Okay. So does anybody have any questions there? Check for a GCF. If you do, see if you can still factor what's left inside the parentheses. Okay, everybody good?
Mm-hmm.
All right. Okay, so on this one, we've got a trinomial. What should I check for first? GCF. Do they have one?
Yes.
Yes, they have a GCF of 2, so factor out a 2
X.
to x. Very good.
Like your 5th mistake.
So divide everything by 2x, so I get 5x squared. Hey, I was just going off of what you guys told me.
6.
What?
I was told there was a GCF of 2.
6.
Hmm? 6.
6. It's like your 6th mistake, Mr. Law.
Yes, no.
All right. So now, check, can I factor this again? So it is a trinomial.
Nope.
Chances are I can factor it, but you're going to need to check. I would go ahead and just set up your parentheses. The leading coefficient is not 1, so I need two things that multiply to be that. So that's going to be 5x and x. And then the two numbers that are going to go here have to multiply to be 6. So my options are 1 and 6 or 2 and 3. You're going to have to try some different combinations. You're checking, does the outer product plus the inner product give you 13? Don't worry about the 2x in front right now. Okay? Does the outer product plus the inner product equal 13?
It's 3 and 2.
Yeah. So what I kind of do is if I look at the 1 and 6, if I put 6 there and 1, I know that's going to be 5 times 6. That's way too big. And if I switch them, I'm just going to have 5 plus 6 is 11. So that doesn't work. So then I try 2 and 3. If I try them this way, that's going to be 3 times the 5, and that'd be 15, too big. So if I switch them, that's a 2. So my outer product is 10x, my inner is 13x. That works. Don't forget your GCF in front. If you leave that off, you are going to lose some points. Okay.
Yeah, maybe we lost 20 pounds.
All right, so check for GCF. Is there GCF?
2.
2.
Not 4, Mr.
Okay. All right, so then I need to look at what's left. X squared plus 15. Can I factor it farther?
No.
No. The only way to factor something with two terms is if it's a difference of squares. This isn't a difference of squares. I can't do anything else, so I just leave it like that. Yep.
We should do one where we can.
Okay, so do these have a GCF?
Yes.
Yes, of 3. So I divide. There is no variables in common, otherwise I would have to take that out as well. I divide by 3. 48 divided by 3 is no.
13.
No.
14.
16.
4 is so good.
Now, is this a difference of squares?
Yeah.
Yes, it is. So I need to factor it farther. And it's easy because I just look for what times itself is that? 3, and then to get x to the 6, it has to be x to the 3rd. Because remember, when I multiply, I add the exponents. Okay. And then I look for what times itself is 16. 4. 1 has to be, to get the minus, 1 has to be plus, 1 has to be minus. And then I need y to the 3rd on both of those. And then, again, bring the GCF down. Okay. And that is it.